All right, so the structure of today's session is modeled a lot on when we went through the ISTE AI course as a faculty group. And so we sort of had, pre-readings or pre-lectures that we consumed beforehand. And then we found it just really helpful to talk through some of these things. So I have a mix of both for you in that I'm going to be sharing some information so that we can talk about it. And I also asked that you had some pre-readings done so that we can talk about that content as well. And the choice to do that was mostly to make sure that we were sort of delivering the information as efficiently as possible. I really liked those two blog posts that I had as pre-readings as intuitive, easy to understand explanations of how LLMs actually work. I hadn't been able to find any source before now that I felt like did a good job without getting too technical or too general, that you could actually sort of understand what was going on. Thanks, Janet, for linking those. So let me share my screen. We're going to get started with what is machine learning. And a lot of this talk is based on the information that I share when I go and teach in faculty fellows classrooms. And so it's sort of like a 30-minute, this is your AI literacy foundation. Here's how AI works, especially related to teachers. And so a lot of what we talk about is how machine learning is similar to human learning, how artificial intelligence is similar to human intelligence, because that's what our teachers know really well, is how children learn and how humans think. So that's how this talk is sort of structured. So first off, for how machines learn, there's a few different types of learning, and I wanted to start with supervised learning because it's a good way of thinking about how machines learn. And so if you have ever seen this image before, it's a training set for machine learning. So for us as humans, we're pretty good at distinguishing between blueberry muffins and Chihuahua dogs, but you can see how maybe if you were a machine and you weren't so good at things, you might get these two things mixed up. So in supervised learning, you get a training set like this, and it's labeled. So it says, this is a blueberry muffin, this is a dog, this is a muffin, this is my thing's pulled up. I can't see what it is. That's a dog, dog, muffin, et cetera, et cetera. And you give it enough examples of muffins and dogs that it starts to create this probability model that helps it say, these are the features I've seen in muffins, and these are the features I've seen with dogs. And it helps create this probability model where it can say, this is a muffin and this is a dog. So that's supervised learning, is when you give it a training set that's labeled and you say, this is this concept and this is that concept. There's also unsupervised learning, where you just give it a ton of data and you say, what are the patterns that you can find in this data? So Google Maps works like this. You don't say, this person's going from this location to that location, it took them this long to do it. It's all of the data from people's phones as they're on the roads, and you can see when people are traveling from one location to another, what are the different routes that they're taking, how long is it taking them in real time to do that. And so that's unsupervised learning. It's really helpful when you just have so much data that you can't have a human really involved in labeling that training set. And then there's also reinforcement learning. And so reinforcement learning is sort of like giving the machine feedback. So you ask it, you give it a new picture and you say, is this a muffin or this is a dog? And the machine says, this is a muffin. And you say, yeah, that's right, or no, that's a dog. And based on the feedback that you give it, it will sort of tune its probability model to be more or less certain about things. And so these three types of learning, they're not mutually exclusive. Like you can have supervised learning and unsupervised learning and reinforcement learning all as part of training the same model. So some things will, lean more or less towards different types of learning, but you can have any of these in any sort of model. So how is this different from how children learn? So let's do an example of how children learn. Say they're trying to learn to classify cats and dogs. their teacher might label an example of cats and dogs, and then kids notice the similarities or differences and create these relational rules. So relational rules are a very unique human thing. As far as we can tell, no other species creates relational rules. And it's just our ability to say what the relationship between two things is. And humans are so good at this that we will do it to things that don't even necessarily make sense. Like if I asked you, how is a box similar to an apple? You could probably come up with some stuff, even though that's like a nonsensical question. So we are really good at creating these relational rules. That's how we sort of make sense of the world, even when there is no relationship to really be found. But kids notice these similarities and differences, such as both cats and dogs have four legs, so maybe that doesn't really provide that much information. But cats tend to have pointy ears, whereas dogs tend to have droopy ears. So that could be a way of distinguishing between cats and dogs. And then kids label a new example and they're affirmed or corrected, especially while they're learning exceptions to the rule. And then a machine, the process looks very similar, at least for an example like this. So if a machine's learning to classify cats and dogs, they might get a training set like we talked about for supervised learning that has examples of cats and dogs, preferably as diverse of examples as possible. And then it creates a probability model based on those features. So having four legs would not provide a lot of information about distinguishing between the two. So that's not going to be heavily weighted in the probability model. But pointy ears are more likely to be a cat and droopy ears more likely to be a dog. So that's probably going to be more highly weighted in that probability model. And then the machine learns new examples and is affirmed or corrected to update that probability model. So some things that are important to think about the distinction between how children learn or humans learn and how machines learn is that we are learning abstract concepts from specific examples. In contrast, a machine is creating a probability model from specific examples. So it's not learning what a cat is, it's learning what are the features of a cat. And when I see those features, how sure am I that what I'm seeing is a cat? Humans also do both inductive and deductive reasoning. So inductive reasoning, you see all these examples and you induct to a abstract concept or a relational rule. And that's what we saw in supervised learning is you get all of these examples and you get this probability model of what this concept is. However, humans can also do deductive reasoning. And machines largely cannot do deductive reasoning. So I can't give a machine an abstract concept and say, now apply it to a bunch of examples without it seeing those examples of that concept. Whereas humans, especially the older that we get, the better we are at learning abstract concepts and rules and then applying those to novel examples. So that's one big difference between humans and machines is that machines are primarily inductive learning, whereas humans can be both inductive and deductive. All right, any questions about that before we move on to human versus AI, or human intelligence versus artificial intelligence? How many of y'all had seen the muffins and dogs, or maybe you've seen the bagels and dogs, or one of those training sets before? Yeah. Yeah, that's actually an old example. That's probably 10, 15 years old, because that was for a different sort of artificial intelligence, which is just machine vision. Any other question or any questions? All right, we'll head back to talk about what is human versus artificial intelligence. So again, with human and artificial intelligence, there's a lot of similarities, but there's also some key differences. So both humans and artificial intelligence, they use sensors. So we use our senses, eyes, ears, all that sort of stuff. Or artificial machines use sensors like, uh, an accelerometer or a light sensor to perceive and represent external objects and language. So we have some sort of input going into the system. And then, like we were talking about with machine learning, humans learn from guidance. They need, compared to machine, they need less structured feedback. So with a machine, you're mostly saying like, yes, that's right. No, that's wrong. Here's the right answer, that sort of thing. Whereas with a human, you could be like, that's not quite right. Try again. And they can learn something from that, like try again, much better than machines can. Humans also are using probabilities to reason and make decisions, and compromise is possible. So if I give a human a choice between A and B, they can say, well, I like this part of A and I like that part of B, and I'm actually going to come up with secret option number C. Whereas if I give artificial intelligence a choice between A and B, because it's based on this probability model, it's really only trying to choose between those two options. That's the probability model is like it's 55% A and 45% B, and so we're going to choose A. And then humans also can apply rules with flexibility, largely because, like, especially if we understand why the rule exists, we can maybe decide whether that rule applies to that specific situation. So, like, if I'm driving home late at night and there's a stop sign and there's like absolutely no one around, maybe I decide to not stop completely at that stop sign. Whereas a AI-driven car, the rule is that you stop at stop signs. And so it's not going to say, well, there's no one around and it's sort of late at night and the chances are that something's not going to happen. It's just going to apply the rule. Like we talked about, humans understand abstract concepts and relational rules. So we have understanding. We're not just using a probability model to navigate the choice between different options. We have an understanding, and that informs how we reason and think about things. And then the perhaps biggest difference, at least for now, between human and artificial intelligence is that humans have general intelligence and we can solve a lot of different types of problems, and we can learn about solving problem A, and that can apply to learning how to solve problem B. Whereas artificial intelligence has no general intelligence so far, and so it only knows how to solve a task that it's been trained to do. And if we ask it to solve some different task, even though I as a human could do it because I know task A, it's not going to be able to solve task B because it can't transfer in the way that we can. And then I wanted to make a quick distinction between computers and AI. So computers follow rules exactly as they have been described by a programmer, whereas AI is able to make a decision. So that's what distinguishes AI from just a computer in general. So for example, if we're looking at something that's mobile, a computer would be a remote controlled car. The human is telling it exactly where to go and exactly when to do it. Whereas AI would be like a robot vacuum that has sensors that can take in information about its environment and make decisions on its own about how to navigate it. And if we're looking at something like information processing, an example of a computer is a calculator. So it's programmed exactly if this sequence of steps goes in, this is the exact output. Whereas AI has these larger models, which we're going to talk about next, that it can make its own decisions about how things, based on the input, exactly what that output should look like, which of course can also get us into trouble, as we'll talk about. All right, before I move on to the next, so next we're going to talk about the information that was related to the readings and how exactly large language models work and some of the advancements in that field. So I wanted to give us time to ask any questions, talk about anything related to human versus artificial intelligence, maybe that you've seen related to your own work or from your students, or maybe some misconceptions that your students have?
Laura, I have a question. So about the human intelligence and AI, artificial intelligence, would you say that AI, taking your example as like a self-driving car and you as a human driving the car, would you say AI is getting more advanced or smarter because it would train itself? So, for example, if like the Waymo on the road, if they see a human being driving the car and then stop at the stop sign, but they don't get the full stop, would they train themselves that, oh, probably I don't have to? Um, and then they will just learn by all the sensors and data and then progress and get smarter, or does it have to be like the input from the trained data? Do
Yeah,
you,
and so that depends, and we'll talk about this a little bit coming
okay.
up. But there's like a difference in the training data that it gets, and then like the like algorithm that it works on.
Mhm.
So if there's a rule in the algorithm side, that's like the computer side of it. So if there's a rule that you always stop at stop signs at the algorithm side, it doesn't matter how much training data that it sees humans rolling past stop signs. It's always going to default. That's always going to trump that data that it's seeing. So it sort of depends whether it will get smarter in some cases.
Great.
And that's why things like guardrails on, large language models are so important, because no matter what deep, dark depths of the internet you're being trained on, there's some things that you shouldn't say. And that's where like AI guardrails come in.
Okay. Cool.
Any other questions about human learning versus machine, or human intelligence versus artificial? Perhaps the biggest thing that we get from our teachers is that there's just so much to teaching that's not intelligence, like not cognitive intelligence. Um, and so, like, if you're looking at that, the difference between human and artificial intelligence, there's also just like all of this other stuff on the human side that especially our teachers do in the classroom. All right, so now we can talk about generative AI. And the reason that there's a parrot on this page is because I want you to think of generative AI as well, I don't necessarily want you to think. How I like to think of generative AI is as a parrot doing improv. So it sounds a lot like it's talking, um, but it's also like it's just repeating things that it's heard. But it also takes a very like yes and approach. It doesn't do a lot of reflection and evaluation, especially like once it gets started, and we'll talk more about this process. But it's just like yes and yes and yes and going on to the next thing. It's not doing a lot of reflective thinking or reasoning. So generative AI, the most common one is a generative pre-trained transformer. So if you ever wondered what GPT stood for in ChatGPT, it's a generative pre-trained transformer. And they're based on large language models. So that was really the technological advancement that allowed for generative AI, was these large language models. And the three-step process, or the process that it follows, is that it understands naturalistic language, and I put understands in quotes because it's very much like is it the Chinese room or the Chinese box, whatever, like it doesn't really understand. It's just following these probability models. And that's what I hope you saw in the readings, is that the first step it takes in understanding natural language is converting it into math, because that's what computers understand. So saying that it understands naturalistic language without the sort of air quotes, I feel like is a pretty big misconception, because it's really just converting it to math so that it can process it and then converting that back into language. And it follows this process of embedding and attention, like was described in the reading. And it uses that to match the prompt that you give it to the training data that it has. And then once it's done that, it generates naturalistic language. And it does this through this decoding and sampling process described in the readings. And that sampling process is really just to add some randomness to the output that it gives you, so that it's not saying the exact same thing every single time. And what it's doing, and why I say it's a parrot doing improv, is that it's just guessing what the most likely next word or phrase is. So it's just yes and, yes and, yes and it's following this path, that's just saying what's the most likely next word or phrase until the most likely next word is nothing, and then it's done. And like we were talking about with Waymo learning from human drivers, it's guided by both a system prompt and a user prompt. So there's a user prompt of what you give it and what you are asking for. And then there's also the system prompt that provides some of the guardrails, it provides some of the tone, it provides some of the like features that especially make different tools feel different to use. So like Perplexity is much more turned up on don't make up stuff, like only provide information that can be verified. Whereas ChatGPT is not, that tuned up on don't make up stuff. And that's why there's this difference in tools, is these system prompts. One of the interesting things I've heard recently about ChatGPT is that, so ChatGPT is known for being very like friendly and amenable. And I've heard that it's one of the failure states that they have recognized for ChatGPT. It's called the sycophantic failure state, where it will just say, yes, yes, that's true to anything you say. And so they're trying to get it to not do that. But that's, part of their system prompt is that it's, supposed to be friendly, and very approachable for people. And then it's also trained on or pre-trained on these large data sets. So one of the principles of AI has been interpretability. And so we want the human to understand how the AI is doing what it's doing so that the human can verify the AI's output. With these large language models, that has broken down a little bit because you can't track what a large language model is thinking. The data set is just too large. So it'd be sort of like trying to track, as you're talking, the neurons going on in your brain. It's sort of like that level of detail. So that has broken down a bit for LLMs, and a lot of people who, do research or create genAI, you'll ask it like, why did it give me this response? And they're like, I don't know, dude. Some limitations of genAI, like we were just talking about, it's a large training set, and that means that you can't really track what it's thinking, especially when it does things like when it tries to do math, because it's not a calculator. There's a lot of, why would you possibly ever answer a question in that way? And you can't track what it's thinking. Another limitation is that these prediction models lead to really generic responses. Because of that process of matching your input to the training data and then just thinking, what's the most likely next word or phrase? It's sort of like the most average of things is the highest probability as it goes through that process. So I like to tell our students that, like, if you want genAI to come up with ideas for you, you're going to come up with you're going to have the most bland, generic ideas possible, because it's just the average of human writing and thought. Incorrect predictions can lead to hallucinations. So if you haven't heard the term hallucination before, it's when generative AI says something with the absolute certainty of being right and it's 100% wrong. And hallucinations happen because as you're going through this prediction model and trying to predict what the next word or phrase is, sometimes that prediction model gets it wrong. And you turn on this path that is not the path you should be on. And from there, you're just doing what's the most likely next word or phrase. And so it just keeps getting, farther and farther off track. And because it's doing improv essentially, it's saying yes, and it's not going back to, oh, that doesn't represent sort of my understanding of this concept or anything like a human would. They're not sort of self-monitoring because they don't really have an understanding to self-monitor. So that's why these solutions sort of sprout out. So I want to point out that genAI can be both wrong based on training data that's incorrect, got incorrect information, and then it can also hallucinate. It can also, in this probability model, pick the wrong path and go down the wrong path. And those two things are sort of different, even though they both end up as wrong answers. And then perhaps the biggest misconception that our teachers struggle with is that GenAI is not artificial general intelligence. So that's what AGI stands for, is general intelligence, meaning that can solve a lot of different types of problems. So large language models can't do a lot of things that you would think a computer would be able to do. Like it's not a calculator. So people ask it to solve math problems. And it can't do that because it's not a calculator. It doesn't have that algorithm background to say when this sequence of events enters, this is the correct sequence of events. All right, before we move on to more advanced concepts, were there any questions or comments about how large language models work, how these generative pre-trained transformers work? Were y'all surprised at all by the readings? Like, yeah. Yeah, I thought they did a really good job of showcasing the, like it's just trying to guess what you want it to say.
Yeah, I really enjoyed reading the two blogs, which is very like easy to understand. I know like maybe 1 or 2 years ago, I know like how LLM works, but it's really accurately, talk about how that really work. And I think our students will be really beneficial to understand how this work. When I talk about AI in my class, I think the biggest problem is not to let them use it, but also like let them know how that work behind it before they using it so that they can be aware of the possibility of it's not based on the fact, but it's just based on the prediction. So that I appreciate the two blogs and all the info you guys shared. So
the two readings I read last night, and they were like eye-opening. And I was like, wow. Because sometimes I ask ChatGPT for advice, and then my son would say, like, Mom, stop asking ChatGPT for advice because it's so flattering. It will just try to guess what you want. And now I realize it's because I think I probably had too much trust before last night. Like ask everything like travel advice and what my kids should do. Should they learn violin or viola? And now I realize like I had more trust, like I shouldn't.
Yeah, one of the heuristics I've heard that I really like is that you should use generative AI for things that you need to be average on, but you should not use it for things that you want to be excellent on. So, like if you just need to, write an email and it's fine for that email to be okay, whatever. But if, you're writing to an important client or, your boss or something like that, maybe you want the extra precision and expertise that being a human involves. But yeah, to Jalu's point, that's something that, I mean, we said it about this session in general was that, you know, the tools that people are using change so rapidly that you sort of need to understand how they work, so that you understand what the limitations are and what the capabilities are, as you're using a new tool. It drives me a little crazy when these sort of like the new models or the new like RAG, which we'll talk about next. Like when RAG first came out, people are like, oh, and now, you know, generative AI is never going to be wrong again. And I'm like, it's still a large language model. It's still like nothing's fundamentally changed about the technology. And so until there's, you know, some technological advancement, I don't see a path forward to like artificial general intelligence or sentience or, you know, all the things that people worry about with AI. Not to say that those technological advancements won't happen. It's just, I don't think large language models are capable of them. Any other questions, comments? I'm glad you found the readings helpful because I thought they were really good. But then I was like, it's hard for me to tell because I'm, you know, steeped in this stuff.
I
But
just wanted to
Ben,
make a
oh, go ahead.
sorry. I just want to make a quick comment about the blog about hallucination because I think the author or the blog writer, he just mentioned hallucination just happens. So the user really needs to be the expert in the content that we're asking for or we're doing. So use the AI as a collaborator, but the user should be the one who knows the content the best. So you'll be able to identify whether it's hallucinating or not, and also like how you can adjust your prompts to be more targeted. And I really like how it explained to make the like embedding and attention, the kind of level of graphic, and how that could translate to the more accurate or the more detailed information or indicator that you can provide in the prompts. You can get a better prediction in the results.
Yeah, it's still no guarantee though. I was gonna ask Ben, I meant to look it up, but is Mark Rydell, is he Dury Long's advisor?
Oh yeah, no, he was not. McGarrico was,
Oh,
Brian
right.
McGarrico. But it's worth saying Mark Rydell is 5 minutes away from us at Georgia Tech, and really I got famous, geez, 15 years ago on doing a lot of work at kind of on the intersection of AI and storytelling, like narrative AI. He's an amazing writer, both academically and then these articles were great to share. So worth knowing he's right here. He does public talk sometimes. And McGarrico is really cool too. They build all sorts of really cool educational tools as well. But yeah, I don't know if it's helpful either. Anyone should feel free to share. You know, if you know, it's a space to just chat about things that are new, and then also folks here may know a lot of other things to bring to the table. But I do think one thing on my mind is for me, Lauren, Janet, and maybe others on this call too, when you work with a lot of computer scientists, as educators, once you know some of this language, you know, RAG, you know, tuning a model, these kinds of things, it really can help you in some conversations in this technical space. So if you have any questions, just share things you know too. I think this today and whenever we do this in the future.
Yeah. Well, and I was asking about Dury Long because she and Brian McGarrico,
Oh yeah.
they wrote in 2020 a like sort of AI literacy paper. And that's sort of like, you know, what are the things that people need to know about how AI works? And I keep waiting for it to get out of date, but I still think
Yeah.
like it's exactly right today. So if you're interested in that, Chenyi.
Oh, I'm just wondering, like, do you think the hallucination problem will always exist?
I think you could, through different techniques, make it so that it's almost not a problem, but it almost makes it a worse problem because then people aren't on guard.
But another question related to that is we call it hallucination, right? Because we don't believe it has real intelligence. Because if it's human make mistake, we make mistake. We just don't know it. But we never call ourselves hallucination. We just say we make a mistake. So I think right here, I'm also wondering like what is the I don't know how to phrase it. What is appropriate reaction to a hallucination? Whether that means we have to be that we have to make our teachers to be content expert, which I don't think that's possible. And with that as part of reality, then I think it could be really interesting to just to see like how to take hallucination as an opportunity of teaching and instruction. Because we can never avoid it, no matter, because that will be like 0.00001 percentage of possibility there is one, right? But yeah, I'm just thinking like, because I also see if we have this idea of controlling or eliminating all the hallucination, then that means we're probably going to raise the bar really high for teachers candidate, which I think may be difficult to achieve. Just reflection.
Yeah. Yeah, I'm thinking of when I try to use AI, so I write article summaries that sort of describe articles. And I tried to use genAI to help me write these article summaries. And I was writing about a concept called legitimation code theory. And I was like, could you write me a definition of legitimation code theory and an example, blah, 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 blah. And it did exactly what I would expect it to do, which was sort of self-explain legitimation code theory based on what those words are. And it was like completely, utterly wrong. And so at that point, I was like, no, that's not it. Legitimation code theory is this thing. And it was ChatGPT. So it was, oh, you're right. Of course, blah, 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 blah. And once I did that, like it could come up with good examples of it. But at a certain point, we do need someone who has the expertise to evaluate. So, for our teachers, I don't think it's too far, especially like in their core content area, to ask them to be the experts. One of the things I really like using it for is to extend skill sets a little bit, but then you're also extending into a skill set that you don't have expertise in, and that, you might end up taking some wrong paths. So there's definitely a trade-off there.
Yeah, and also another thing I think I was sharing this news I heard is like in China, from central government level, they have this really clear cut saying like K-12 would not allow to use AI at all. Like they can have AI courses, but they're not allowed to use AI at all for any assignments or any school project at all, like period. And then now when I think about it, I think it's somewhat also protect teachers, because if students have access to AI, they come up with something that's outside of teachers' expertise, then it will run into lots of ethical problem, and also the difficulties to to have this effective instruction in classroom, I guess.
Yeah.
But that's also like something that will not happen in the US for that kind of policy. But I'm just wondering what can be appropriate way to handle that dilemma.
Yeah. It sort of reminds me of like working on dissertations. I'm reading Ben's student dissertation right now. And by the time a student gets to a dissertation phase, it's like they're talking about all sorts of stuff you have no idea about. And it's like, how diligent do I want to be in, doing my own research to figure out whether what they're saying is right, or how much do I want to trust them and, let them be the expert. So yeah, I don't know that there's a good answer to that. All right, for the interest of time, let's talk about some of these more advanced techniques. So some advances in GenAI. So one of the big advances sort of early on was retrieval-augmented generation, or RAG. And so, y'all read about these, so I'm not going to go in them in super detail. But basically what RAG does is it takes, all of the training data of the large language model, and then it says, but also here's some specific documentation that's going to give you a better answer. So here's some specific locations to look for information. And so if you thought of the process of using a GenAI as this first series, that it goes to the user, and then the LLM, which includes all of the pre-trained large data, and it goes back to the user. With RAG, it goes to the LLM, and then it goes to a retriever or some other sort of set of documents. And that informs what information is like high probability top of access for the LLM, and then it gives it back to the user. So like the blog said, it doesn't stop hallucinations completely, but it does make sure that it's at least accessing the right training data and that the information that you're looking for is higher probability as it goes through creating that output. And then chain of thought is not something that I was super familiar with before I read the blog post. But I did know early on, people figured out that if you just ask it to think step by step, it produces these better results. And that was one of those things that you asked, the AI developers and scientists and everything. You're like, why does that work? And they're like, I don't know, dude. But so chain of thought is just something that's now built into the system prompt that basically asks it to think step by step. And the thinking is that this sends the LLM like to better the pre-trained data set. And so it gives it better information to start with. And then it also has a more like systematic way that it's thinking through the response. And then agentic AI is the big one currently. And my impression is that people seem to think that agentic AI is just going to solve all of our problems with generative AI. And I think what is really happening is that it's solving one of the biggest misconceptions about generative AI, which is that it's a computer that can talk. And so with agentic AI, you have all of these agents that are not, they might be AI, they might not be, but say a calculator is an agent. So now you can talk to an LLM. It will pass the information that a calculator needs to run the actual computer program that follows specific sets of rules to get the right response. And then it gives the answer back to the LLM. And now you can get a correct response for the user. And so it's really just outsourcing different tasks to programs or software or tools that are designed to do those tasks. So you can use it to like check the weather, and instead of it just making up weather, it will actually go to a weather source and pull the weather, like current data, and all sorts of things. These are really popular in companies, especially companies that have like highly specified processes for doing things. They've developed their own agents for reviewing different types of documents or that sort of thing. Anything that's been highly specified before is a good, or like created a computer program before is a good way of creating an AI agent that is used in this agentic AI workflow. But again, it addresses the problems that we have with AI and the limitations that we discussed, but it doesn't solve them because it's still a large language model. There's still opportunities for generic responses, incorrect responses, hallucinations, all those sorts of things. All right, was there anything we wanted to talk about related to those advances? How many of y'all have heard of agentic AI? Yeah. Yeah, it's a big thing.
So I use the DeepSeek sometimes to ask questions, and DeepSeek is very funny. it gives all the detailed thinking process, and they show you what they were thinking. And like if I ask, like, okay, I go somewhere, what kind of transportation would you recommend? A DeepSeek would like think aloud, say like, okay, I think this is a female, wants to travel, so I need to warn her of a safety issue, or and sometimes the recommendation was wrong. So, but when I see the thinking process, and I would say, oh, actually, I'm not for travel. I just go there to work, and it's very funny because it make a lot of assumptions of the person asking the question, and it's very personal. And sometimes they say like, oh, this person doesn't seem to know much. Oh, this person seems to know very little about cars, or like. So I enjoy reading the thinking process just to see, like it's like that's a lot of disclosure. I haven't seen that in ChatGPT, like disclosing all the thinking and the little thoughts.
Yeah, and that could be a tricky part of using, if it's not disclosing, of using genAI, is what assumptions is it making that, information I haven't provided that maybe it's assuming incorrectly. Any other questions or comments? Well, that's actually a great segue into what we're going to talk about next, which is prompt engineering. So prompt engineering is just the science/art of getting genAI to give you a good response. And so in prompt engineering, it's like the way to get it to give you a good response, like Janet alluded to earlier, Halinga was just talking about, is to give it as much context as you can. And our teachers often forget this step, and they'll get sort of random stuff, and they'll make this mistake a few times of not giving it sort of context around what your sort of general goals are, that they'll get bad responses a few times, and then they'll start learning to give it better context. So in a prompt, sort of the 4 steps that I follow are give it context. So for example, I might tell that I'm a professor in a college of education in the US. A lot of models nowadays will store information about users and sort of carry it forward to new prompts. So it sort of learns, it creates this profile for you. I still give it context, especially if I'm trying to highlight different like aspects of my role. Like if I'm trying to write to a lay audience versus trying to write to an academic audience, I'll give it that context. And then I give it the assignment objective. So for example, I want to write a discussion prompt for the first 15 minutes of class about how AI can support students to achieve higher levels of Bloom's taxonomy. And then give it the task that you want it to do. Create a list of 3 discussion prompts for pre-service teachers on this topic. And if that's not included beforehand, give it the format of the output. And so giving it the format that you want it in is a really like key tip to getting a good response out of it. And so this is, something that I might not have bothered to come up with a discussion prompt beforehand, because it would take me, 15, 20 minutes to come up with a discussion prompt for this little activity in class. But now I can ask ChatGPT to give me 3 ideas, and in a couple of minutes, I can have a prompt that I can then tweak to my specific students and my specific class. And it just helps me to create like more engaging instruction. Some other tips and tricks: give it small tasks using the prompt engineering basics. The more you can break down a task, the less space it has to hallucinate and to take a wrong path and to go off the rails. So the more you can break down a task, the better responses that you'll get, even if you are the one who has to sort of stack those tasks together. It's also really helpful to give it examples to follow or content to adapt. If you give it no examples, that's called 0-shot prompting. If you give it 1 example, to follow that's called one shot, or you can give it like multiple examples, and that's multi-shot prompting. And the one shot or multi-shot prompting produces a lot better outputs. Of course, treat outputs as first drafts that need to be refined or reduced and then applied to your students. So, what we always tell our teachers is you're the one who knows your students. You know what they're like that day. You know what they learned last week. You know all these sorts of things that you just can't provide in context. And even if you did provide in context to ChatGPT, it wouldn't necessarily know what to do with. So you still need to be the expert on how you apply outputs to your class. And then be wary when asking it to solve a problem with a single right answer. We once had a teacher ask us, like, can ChatGPT do my taxes? I'm like, it can give you something that looks a lot like taxes. I wouldn't turn it into the IRS because it's definitely wrong. But so if it's got one right answer, I wouldn't trust ChatGPT or any generative AI to give it to you. But especially if you're picking like from 5 different examples, I find that that's a useful way of using it, is to sort of say, give me a few different options that I can then pick from. And so I don't have to do that brainstorming all by myself. However, I also found that a lot of the outputs it gives me, they make sense on the surface. And then once you start thinking about them a little bit more deeply, sometimes they sort of fall apart. So some of my personal favorites for how to use generative AI is to prepare to have an intelligent conversation. So say I'm trying to learn about something that I don't know anything about. For example, I had the windows in our house replaced recently. I don't know a thing about windows, and that's not a good place. Like, that's not a good feeling to go talk to a salesperson and know nothing about the field that they are selling you. And so I use ChatGPT to, like, what are the different types of windows? What are the different features? What are the different, blah, blah, blah. Just sort of like give me the outline, some of the terminology that I need to have an intelligent conversation with someone who can actually answer my questions for my specific context. I also really like it to express ideas to general audiences. So I've spent a lot of time practicing how to express complex ideas to academic audiences. And I'm not very good at expressing those ideas to general audiences. So, like I tell our teachers, don't use it to come up with ideas, but it can help with that expression of ideas because it's so fluent in its language. It's also pretty good at giving real world examples of concepts, as long as you make sure that it's understanding the concept correctly. Like before, when I was talking about legitimation code theory, it could come up with good examples once I clarified what exactly that concept was. We briefly touched on this before. I like to expand skill sets, but there's the difference I talked about between doing something that's average and doing something that's excellent. So for example, there's a social studies teacher that I've heard uses generative AI to do like data science and data analysis in his class. So it's not a skill that his students know how to do independently. And it's also not something that they need to get absolutely right, but he can give them data, from the US on obesity rates or on migration patterns or like all sorts of things. And they can do data analysis to get a sense of the concepts and use big data to improve their learning about human geography, without spending a couple of semesters in a, statistical methods class. I also really like Grammarly because I tend to type wrong things all the time. So it's really good at helping me catch typos and grammar support without spending so much time looking line by line, and doing like tone checks, especially writing for different audiences. However, I noticed that Grammarly like doesn't do grammar right all the time anymore. I think it might be what Janet's talking about, that it's starting to like learn from the things that people do but aren't necessarily right. So I've had to tell it like, no, that's not right, quite a few times, especially lately. But those are some of my personal favorites. Do you all have any favorite ways of using GenAI? Oh, thanks, Janet, for putting those prompting resources.
I think my favorite way of using those generative AI tools like ChatGPT, right? I think I use it a lot with my class, like generate some of the creative ideas of hands-on activities to teach my students how to use AI in different activities. It's very context specific. So it helps me a lot with my course design. And then sometimes I didn't think of, I can use this activity to introduce my students with these concepts, and these give me a great idea to start with. And of course, I have to tweak the content and the context. So that's my favorite part. Like, it's a really good tool to aid my teaching part of that. So that's my personal experience. And also like the grammar, and then like tone track with my writing, and also my email writing sometimes it saves me a lot of time.
Yeah.
I think ChatGPT is really good at real world examples. So for example, when I'm designing quiz on like testing reliability, it's a very dry concept. And then I will ask ChatGPT like, can you create some real life examples about reliability for a quiz item? And then it has all those very vivid, stories, examples, and I feel that's very neat.
I do want to recognize that it's 1. So if anyone needs to hop off, go ahead. I'll stick around just in case anyone wants to keep chatting, but we can pause the recording here.